Hi, hello. Now, a numerical, a large slab of mass 5 kg lies on a smooth horizontal surface with a block of mass 4 kg lying on the top of it. The coefficient of friction between the block and the slab is 0.25. If the block is pulled horizontally by a force 6 newtons, then the work done by the force of friction on the slab. Okay, so work done by the frictional force we have to find. See, try to understand the question here clearly, step by step we can do. Okay, so for this, now initially small m is the mass of the block and capital M is the mass of the slab, that is given as 4 kg and 5 kg respectively. Now capital F is the force acting on the block. Okay, so where is the frictional force takes place? The frictional force takes place between the two blocks, that is mu, which is equal to 0.25. But here frictional force mu, which is equal to 0, that is smooth floor. Only frictional force takes place between the block and the slab. Try to understand, the total system is moving with an acceleration a. So total system is moving with an acceleration a. Okay, so step by step we can do here. So for first one, step 1, in this acceleration of the system, so that is a letter. So a, which is equal to force divided by total mass of the system. So force divided by total mass of the system is capital M plus small m. Okay, so then we can write here a, which is equal to force is given as 6 newtons divided by mass is 4 plus 5. So then acceleration, which is equal to 6 by 9, that is 2 divided by 3 meter per second square is equation number 1. Okay, so 3 2s are 3 3s are. Okay, so we got 2 by 9. And next step for this, step 2. So I wanted to find the maximum frictional force. See, try to understand here, this is the upper block, and next taken there is small gap, just assuming, this is the lower block. So for this is small m, this is capital M. So what is the force takes place between them? Downward direction is mg acting here, downward direction is mg acting. And also normal reaction is acting like this on this body. Normal reaction is this. So here n is equal, what is the value? mg. N is equal to mg. So for this maximum frictional force I am going to find, that is F maximum, which is equal to mu into n. So that which is written as F maximum force, which is equal to mu into n is equal to mg. N is equal how much? Mg. Both are equal in magnitude, opposite in direction. So here F maximum value, which is equal to mu is 0.25. Mass is 4. So upper block only considering. For the maximum friction. Then next G value is 10. This is get cancel. We got here F maximum, which is equal to 10 Newton. So here we can take, this is the maximum frictional force on the upper block. How much here we got? 10 newtons. And next one is step 3. So step 3. For step 3, try to understand here. One thing we can clearly understand, that is maximum frictional force is greater than to the applied force. F is the applied force, okay, and F max is the maximum frictional force. And also we can write here F maximum, which is greater than to the F is the frictional force between the blocks. Okay, so this is the frictional force acting here. This is the frictional force F. Here also frictional force takes place. Okay, so here also frictional force takes place, that is F. Here also frictional force takes place, F. So this is acting like a action and a reaction pair, so that due to the acceleration here, applied force, frictional force is acting on this body is F. So for the upper block. But due to the frictional force between the two bodies and on the lower block also, towards the applied force direction there is a frictional force. That frictional force try to pull the down body, that is the slab is pulled by the block. Slab is capital M is pulled by the block. Try to understand this. Okay, so now step 3. For step 3 conditions I wrote. Okay, so here the slab is pulled by a block. Okay, so that's why the frictional force F is equal to capital M into A. Try to understand, this is the maximum friction, but we are finding the frictional force takes place between the two bodies, that is F, which is equal to MA. So for this F, which is equal to M is capital M, that is mass of the slab. Okay, so I wrote clearly what is small m and what is capital M. Small m is block and capital M is slab. So the phi into acceleration value is, that is 2 divided by 3. We got here F, which is equal to 10 divided by 3 Newton. Okay, so this is taken as equation number 2. Okay, so why we are considering maximum friction? Just for the comparison with the applied force and also frictional force between the two blocks. Okay, here frictional force is maximum comparing to the applied force. We got the relation. This is 10 Newton is greater than to the 6 Newton. That's why the upper block pull the lower slab. Okay, now work done by the friction we have to find. So that is step 4. Okay, now step 4. In step 4, that is work done by the frictional force. Okay, for this I'm going to write W, which is equal to, that value is force into displacement. The displacement given in two conditions. Okay, for first condition is t is equal 2 seconds, and next condition is t is equal to that S2 value, S3 value we will discuss. Just I am writing the formula, that is S3 minus S2. Okay, so simply here work done, which is equal to force into displacement formula. Please note this. And now continuation, we have to find the S2 and S3. Okay, at t, which is equal to 2 seconds, then the displacement is taken as S2. For S2, the basic formula S is equal to ut plus of at square. So initially the system is in rest position. That's why here u is equal to 0. So S2, which is equal to 0 plus 1 by 2 at square. So here S2, which is equal to 0. Okay, no need to write here 0, directly writing 1 by 2. Acceleration is how much we got? 2 by 3. Okay, into time is 2 second whole square. This 2 is get cancelled, then S2 value, which is equal to 4 divided by 3 meters. Okay, for second one, so that is at t which is equal to 3 seconds, the displacement is taken as s3. So now s3 which is equal to 1 by 2, acceleration is 2 by 3, and time is equal to 3 square. So this 2 and this 3's get cancelled. We got here s3 which is equal to 3 meters. So we got s2 value and s3 value, then both are replacing in this equation. Okay, so now continuation step 4. So for that, W which is equal to frictional force into S3 minus S2. For this, F value frictional force is 10 divided by 3, 10 divided by 3, and here S3 value is 3 and S2 value is 4 divided by 3. So then continuation work done which is equal to, this value is 10 divided by 3 and this is 5. 9 minus 4, 5 divided by 3, so that is 50 divided by 9. So the work done here, writing W which is equal to 5.55 joules. This is work done by the frictional force. This is the continuation step 4. Okay.